Bismillahirrahmanirrahim. Students, welcome to virtual session of week 11 of Database Management Systems course. If you can hear me properly, please raise your hands. Okay, thank you. So we were talking about distributed databases in our face-to-face class, and there was an example of theory optimization which was left, and I told you that this requires time and I'll explain it to you in the virtual session. So before proceeding to the example, I want to ask if you have any questions from the content we studied in class. Any questions? Okay. So now I'm going to proceed further. So this was the example which we had to solve. Now, since we are talking about distributed databases, and as I told you that distributed database is the one in which the query is executed at different locations. So when the execution of query is distributed, it is called distributed database. So this whenever we are processing the distributed query, it requires different steps. The first step is to translate that query into the query language, and then to convert that query into the algebraic operator or algebraic expressions, and then to decide that which component of the query will be executed at which place. So although the query will be handled as it is handled in a centralized system, but we sometimes distribute query according to the contents which are located, because we are performing vertical and horizontal fragmentation as well. So we may be performing, and the data items may be replicated at different locations. So we are concerned about the localization issue as well. Then what we do is that we are concerned about optimization, because there may be multiple ways a query can be executed, or this query, a certain execution strategy can be selected, but we want to select a strategy which is the optimal one. So that's why we are concerned about the cost of, when we say that I want to optimize my query, it means I want to reduce the execution cost of the query. Now the execution cost in the distributed database also includes the communication cost, because when we are saying we are executing the query distributedly, it means the cost of communicating communicating the relations, or the cost of communicating the results is also important. Now, if we are executing query in a database, distributed database, which is in the local area network, then this cost can be ignored in some way. But if the query is being executed in a wide area network, so at that time the communication cost is very important. So we are then concerned about the optimization of query in this way that the communication cost is also reduced. So the issue in query processing in distributed database is to reduce the cost of transferring data over the network. Now the data is the files, like the database files, the relations, and the results of the query as well. So this cost is high, so some optimization is necessary. So now let's see an example about it. Suppose we have two relations. One is of employee and the other is of department. The employee relation is at site 1, and we are now talking about the network can be any. It can be local area network, or it can be wide area network. But we are saying that there is site 1 at which employee relation is located, and there is a site 2 at which department location is located. Now employee relation which is at site 1, it has 10,000 rows, and each row size is 100 bytes. It means how much will be the size of the table, complete relation? It will be 10,000 multiplied by 100 bytes. So it becomes 10 raised to the power 6 bytes. Okay? So now what is the attributes it is having? It is having first name of employee. It is having minit. It is having last name. It's having SSN, Social Security number, birth date, address, sex, salary, super SSN, or department number. There are multiple attributes for this, and all of these are summing up to 100 bytes. And the first name and the last name are each of 15 bytes. So 15 bytes for first name, 15 bytes for last name. Okay. So this employee has 10,000 records, so the 100 bytes multiplied by, it will break up 10 raised to 6 byte size. Okay. Now the department relation at site 2 has 100 rows, and the size of each row is 35 bytes. So we can divide it in any way, like the department name is suppose 4 byte long, or D number is suppose 4 bytes long, D name is 10 bytes long, manager SSN is 9 bytes long. So all of them are summing up to 35 bytes. And when I want to measure the total size of the table, it will be 35 multiplied by 100, which becomes 3500 bytes. Now if I have a query, the query is to find, for each employee, retrieve employee name and the department name where the employee works. So if I write query in relational algebra, it will be like to project the first name, last name, and department name, like the first name of employee, last name of employee, and the department where the employee works. So it will be the projection of these operators, and we'll be forming the join on employee and where the department number, D number equal to DN equal to D number from department. So this is what is required to do. The result of this query will have 10,000 tuples. And why we are saying that 10,000 tuples? Because we have 10,000 employees, and we are making an assumption that every employee has a department number. Okay. So if we want to project the name of employee, name and a department number, so the result will have 10,000 tuples. Now suppose each result tuple is 40 bytes long. So how we can say that it's 40 bytes long? Because we want to come up with the employee first name, last name, and department name. So first name is of 15 bytes, last name is of 15 bytes, so 15 plus 15, 30, and the department name is of 10 bytes. So it makes up to 40 bytes. So each result tuple is 40 bytes, so it means the result will have 40 bytes multiplied by 40 multiplied by 10,000, which will make 40 multiplied by 10,000 bytes. Now how the query is executed? The query is submitted at site 3. We are assuming that at site 1 we have employee relation, at site 2 we have department relation, but we are going to collect results at some other site, which is site 3. We want the results. We want to send the results to site 3. Now the problem is that employee and department relations are not present at site 3. So the site 3 needs to produce results by collecting the data from site 1 and site 2. Now there are multiple options or multiple strategies to perform this task. The first strategy can be transfer complete employee relation and complete department relation to site 3. So how many bytes will we transfer in total? You will be transferring total 10 raised to 6 plus 3500 bytes. And why is it so? It is because the size of employee table is 10 raised to 6 bytes and department is 3500 bytes. So you will be transferring 10 raised to 6 plus 3500 bytes, total this number of bytes to site 3. And at the site 3 you can produce results. And this is the communication cost. Now the second strategy can be transfer employee to site 2. Because site 2 has department relation. Transfer the employee relation to site 2, execute join at site 2 and send the result to site 3. Now what will happen? The query result size will be 40 multiplied by 10,000. And why is it so? Because you are saying that you will be transferring the results, transferring the results to site 3. So the result size is 40 multiplied by 10,000 and total transfer size is 400,000 plus 10 raised power 6, because this is the table which you transferred, which is employee relation which you transmitted from site 1 to site 2, and this is the result size, because each result is of 40 bytes long, so 40 bytes multiplied by 10,000, it becomes 400,000 bytes. So the total transfer will be 1400000 bytes. Now the third strategy can be transfer department relation to site 1, because department relation is shorter in length. Execute the join at site 1 and send the result to site 3. Now in this case, the total byte transferred will be, this is because this is the result, 400,000, so this cannot be avoided, plus 3500 is the size of department relation. So you are transferring department relation to site 1, you are executing the query, and then you are transferring the total results, which is 400,000, to site 3. So the total byte transfer is 403500 bytes. So the optimization criteria is minimizing transfer. So which strategy we should prefer from all these three strategies? Which strategy is better? Any other answer? Yes, the last one. And why the last one? Because the amount of data transfer is minimum from all the three strategies. In first it is 1003,500, in the second it is 1400000 bytes, and in the last this is the minimum number. So the minimum transfer, because if this number is higher, it will increase the communication cost and the cost of query. So this is minimum. So the last one is the correct answer. Preferred approach is strategy 3. Now consider another query. This Q prime, for each department, retrieve the department name and the name of department manager. So let's go back and see how it looks like. Okay, now for each department, retrieve the department number and the name of department manager. It means you will see the manager SSN from here, and then you will locate the SSN over here and you will find the first and last name. For each department, retrieve the department name and the name of department manager. So it means the relational algebraic expression is project, first name, last name and department name, and from employee relation, and matching, you are matching manager SSN with SSN. Now the result of this query will have 100 tuples. And why 100 tuples? Can anybody tell me why 100 tuples? For each department, find the department name and the name of department manager. Why it is going to be, the results will have 100 tuples? Yes, because in the department table there are 100 tuples, and we are going to find the name and the name of department manager of that department. So there are 100 departments, so it means the results will have 100 tuples. So the result of the query will have 100 tuples, assuming that every department has a manager. The execution strategy is transfer employees. Let's see the execution strategy. Transfer employee and department to the result site, it means site 3, and perform the join. The total bytes transferred will be 10 raised power 6 plus 3500 as it was previously. So you are transferring all the data to site 3. So this is highest, and the highest is quite high. Now the next is transfer employee to site 2, execute join at site 2, and send the result to site 3. Now query result size is 40 multiplied by 100, and why it is 40? Because the department name, first name and last name all are taking up to 40 bytes, like 15 bytes for first name, for 15 bytes for last name, and 10 bytes for department name, so it all makes up to 40. And we have to do it for 100 tuples, so it will make 4000 bytes. The transfer size total is 4000 bytes, which we will be transferring from site 2 to site 3, and 10 raised power 6 bytes, which you transferred from site 1 to site 2. So this is the total transfer cost. Now the third strategy can be transfer department relation to site 1, execute join at site 1, and send the result to site 3. Now when you will be sending department relation to site 1, the size of department relation is 3500. So you will send 3500 to site 1, execute your join over there, and execute the query and send the result, which will be 40 multiplied by 100, which becomes 4000. So this will be 7500 bytes. So which strategy is the best from these? Yes, the third one, because the transfer is minimum in the third strategy. Now suppose another scenario, and we are thinking that the result site is 2. Suppose there is no site 3, there is site 1 which is having employee relation, there is site 2 which is having department relation, and the site 2 need to produce a result. Now the possible strategy can be transfer employee relation to site 2, execute the query, and present the result to the user at site 2. Now this requires total transfer of 10 raised power 6 bytes for both queries, because you will have to transfer the complete employee relation to site 2, and now site 2 can produce the result. Okay. The second strategy can be transfer department relation to site 1, execute join at site 1, and send the result back to site 2. Now this would require 400,000 plus 3500. And why it's 3500? Like if we talk about query 1, for query 1 it required 400,000, because it was 40 and 10,000, 40 bytes and 10,000, so it required 400,000 plus 3500 bytes, and for query 2 it would require 3500 is the department table size and 4000 is the result size, so it would require 7500 bytes. So now here you can see that the strategy 2 is better. Now the same things which we have done over here now, that we pick one strategy from all the possible strategies, and the strategy we pick is the one which gives us the minimum cost. Now this when we try to we formalize it, so we call it semi-join. Now the solution to this is to, or you can say that it is not a good choice, or it is not a good strategy to transfer all the data from one side to the other, when we only need is only a few attributes from there. Like we required only the first name, last name, and the department numbers from there. So it was not a good choice to transfer the whole table. So it would have been better if we only send the attribute of interest to the other side. So we choose an option of semi-join, which is an operation the objective is to reduce the number of tuples in a relation before transferring it to another site. So in semi-join, what we do is that instead of transferring the complete relation, we reduce its number of tuples and send only the tuples which are needed. So the example execution of query 1 or query 2 can be project the join attributes of department at site 2, like we required the department name. So project that attribute at site 2 and transfer them to site 1. For first query, it will be 4 bytes for the size of department name. So you are sending the department names of all, which will take 400 bytes. True. So you will be transferring 400 bytes from site 2 to site 1. And for the other query, you will require 900 bytes to be transferred. Now join the transferred file with employee relation at site 1. Now you are joining the transfer file employee relation at site 1 and transfer the required attributes from the resulting file to site 2. Now what you are doing is that we know that site 2 is the result producing site. So what you are doing is that you have got the attributes from site 2. You are joining them with the attributes like first name and last name from the employee relation, and you are sending only the required attributes to the resulting site, which is site 2. So for query 1, you will be sending 34 multiplied by 10,000. So 34 bytes will be transferring, and for query 2 will be sending 3900 bytes. And then when you transfer all this data, and why I am saying 34 bytes, because you are transferring for query 1, you are transferring department name, department number, and the first name and last name. And for the other query, you will be transferring first name, last name, and 9 bytes for manager SSN, because you require the manager SSN. So you are sending this data. And now what you are doing is that you have performed the join at site 1, and now you execute the query by joining the transfer file with the department and present the result to the user at site 2. So this is an example execution using semi-joins when you are producing result at site 2. Okay, is this example clear? Okay, now let me give you a question. From it. Have you got the assignment from this chapter so far or not? I think you have got assignment 4, and you are required to solve 23.21 and 24.32. It means you have not received the assignment question from this chapter so far. Okay, let me see which question is in your next assignment. I'll give you some other question besides assignment to solve right now. Okay, students, you can solve this question. Let me place the figure as well. This is from your textbook. For this question, I would say that you calculate the cost of execution of this theory. You can make any assumptions on your own about it, about attributes. You can make your own assumptions. students, any questions? Okay. I would suggest that you pick up two relations and practice about calculating the cost of communication for any given query. So pick up any query, pick up two relations, make some assumptions that they are located at different sites. What would be the cost? Okay, this is one of your exercise question which I have placed over there, but it is not particularly meant for calculation of communication cost. But you can see, you can consider it for that as well. Like this, because this is linked with the figure 25.9, which is given in your book. So you have to go through that as well to understand it. So this is the relevant part of. I'm going to paste the relevant part of figure 25.9, or you have to solve this question. This is the information which you will use for it. Okay. Okay. Now I'm going to stop over here. I'm turning the microphone on, but I'm available. So meanwhile, if you find any questions or you find difficulty in doing anything, you can ask me. You can type in the chat panel, or you can raise hand. I'll answer you. Okay. Thank you very much.